If you watched the previous video till the end, by the way, you have to watch the video or else you won't understand much of this video. We were successful in creating two files. One for the image classification, which is this image classification.py file, and this Arduino.py file, which will talk to the Arduino of the commands which it gets from the image classification file. However, in today's video, we will be learning the logistics of integration of these two modules. You might be thinking it's pretty obvious to run them in series, but there are some of the pitfalls. It is quite annoying to run them in series. I'll explain you why. So to do start running them in series, this is how you would write the code. You can take an input of the COM port, give a serial connection, and whenever a motion is detected, we can directly write the command to the Arduino and then validate them. However, if something goes wrong either in the Arduino servo, for example, if you have a 180-degree servo and if the servo is given an angle less than 30 and the servo will start twitching, or the image classification and a face is not detected, then, or if you have multiple face, how will it handle such situations? Again, there are multiple ways of handling these exceptions. The way I am doing it is just let go of the code which is coming under exception. If a face is not detected, don't move the servo. If the servo is less than 30 degrees, then restart the servo in its initial position. And because they are running in parallel, one of the code is not a bottleneck to another, and one can be let go of when an exception or error situation occurs. For them, what I would suggest is having a threading concept. Why would you use threading rather than multiprocessing? Threading concept is better here because we'll be going back and forth from the image classification and the Arduino code. You have to write the command, read the command simultaneously. So hence we will have to make it a threading rather than a multiprocessing. Having that out of the way, we will start with the Arduino file. What I am doing is I'll have 3 lines of commands. I received the current up down value to the servo and the current left right value to the servo. To do something like that, we will have to refactor some part of the code, which would look like this. We will have the COM port as a variable, and hence we can rename the COM port whenever we run the code. Next, we will have a serial port object called add, which will have the COM port and 9600 as the baud rate, because we are using strings to communicate using the serial port. We will have time.sleep. Now you see the advantage of running them in threads. Because this thread will be in sleep, the other thread will still be running. If we had the same situation, if the code were in serial, it would have broken the entire thing. Next, we will have 2 variables, command left right and command up down, which will have the current position of the left right and the up down. Next, we will have an infinite loop, which will have the command as a string, which will be concatenated with a comma in between. Next, we will visualize that command and then write the same command to the Arduino. The string.encode will encode the command in bytes. Next, we will have 3 outputs to read what the Arduino got as an input. Moving on to the Arduino code, it's quite self-explanatory. We will have 2 servo objects, one for the x-axis and the other for z-axis. Going down to the setup part, we will start the serial port in 9600 baud rate. Next, we will have the servo attached to 2 different PWM output pins, PWM output digital pins. In the void loop, we will have a delay each time the loop runs. Next, whenever a serial is available, we will parse both the x and the z. In between, we will have the comma separating them. So whenever we detect the comma, we know that they are in sync. Wrapping up all the codes together, we will have at the end two threads. One thread for the function face classify and the other thread for arduino.py. In both the files, we will have the commands, which is left right command and the up down command, as global variables, so that it is accessible for both the functions. Multiple different types of feedback control systems used. The most popular and predominant being the PID control system, which stands for proportional, integral and differential. We will not be going through the specifics of PID here in our video. However, just for our understanding, there are three different types of controllers. This feedback control loop calculates the error by taking the difference of the output from the system. A proportional controller will usually have a proportional output for a given input, but we are using something called as an integral controller. An integral controller will increase the value until it finds it nearer to the expected output. Hence, in the video further, you can see if my face is left of the camera, he'll increase the value until he finds my face in the center of the screen. So now it's already working out. So I have a DSLR over there. I have, if I move left, yeah, move left. If I move right, yes, works. If I move down, and it works like